Children, can you see the steam coming out of this bowl? This is hot water and the steam is coming out of this bowl. Yes? So this is basically gas. This is an example of gases. The air which we breathe, yes, the air which is filled in the balloon, oxygen, carbon dioxide, all these are examples of water vapor, all these are examples of steam. Sorry, all these are examples of gases. Okay, now we will learn about gases in detail. Let me put this container apart. Okay, now see. You can do one experiment. You can take up a balloon and blow air into it. What happens? It actually swells up. It becomes bigger and bigger. And why is it becoming big? Why is it blowing? Because of the air which you have filled inside. Have you seen a football? A football is what? Actually, it is what is filled inside it? It's air. So all these things are actually filled with air. Although we cannot see it, but air can be felt. We cannot see it, but we can feel the air. When the cool breeze blows, okay, when the fan runs, we can feel the air, of course. Okay, so now what are the basic properties of gases? What are the basic properties of gas? So first of all is, gases, they do not have a fixed shape or a fixed volume. They neither have a fixed shape nor a fixed volume. The shape is not fixed and the volume is also not fixed. Yes, because see, gases in gases, the intermolecular space is too much. It's very large. So the molecules are spread aside and they actually take the space. Whatever they get, they take up the space and it actually dissipates in the environment. So what happens? You cannot actually pack the air. You cannot actually stuff the air. You cannot keep air in one vessel or one container. It is everywhere because of the molecules, because of the loosely packed molecules. The intermolecular space is very large. So it does not have a proper shape. You cannot give a shape to the air. Okay. And you cannot actually find out its volume also. It's very difficult to find out the volume. So they do not have fixed shape. They do not have fixed volume. Now, they are free flowing. Free flowing means not like liquid. Actually, they keep on flowing. They keep on moving here and there, everywhere in the environment. Whenever, okay, it dissipates in the environment, in the area near it. Like the steam. I cannot actually hold the steam unless and until I put some vessel on it. I'll put some lid on it. I cannot hold it. It will keep on dissipating. It will keep on coming out and then mixing in the environment. Okay, those vapors will mix in the environment. Okay, now have you understood about the shape, about the volume, about intermolecular space? Yes. Now one more important thing is the molecules of gas are there very, very far apart, farther than liquids. That is why it is very difficult to compress gas. Although nowadays we have technologies, we have techniques to compress gas, but still it's very difficult to do that. Okay, now let's do a simple experiment to show you that gas actually dissipates in the environment and occupies the given space. Like suppose I have a room freshener here. Okay, now what will I do? I will spray this room freshener. Now what will happen? As soon as I spray this room freshener, it will occupy whatever space it gets. It will not be contained or it will not be restricted to one area. Suppose I want to spray it only in this area. But will it be so? No. Yes. What will happen? It will take up whatever space it has got, and as soon as some other person or as soon as I try to smell it, what will I get? I will get a nice soothing aroma, nice soothing smell, because the vapors in this, the water vapors, the fragrant vapors in this, they have dissipated in the environment, in this room. So that's why a nice magical aroma will come, because the air particles have now moved everywhere. Okay. So now see this. Now can you see? Yes. Now what happens? Will that vapor be restricted in only this space? No. It will actually move around in the whole room and it will make the whole room fragrant. Same with Deodorants. You all must be using, your mamas, your fathers, they all must be using deodorants. What happens? Deodorants also have water vapors in. Fragrant water vapors. Okay? They are basically gas. Okay? Along with vapors. So what happens? As soon as you spray these, what will come out? Again the gas will come out and the vapors will come out. Okay? So what will happen? It will start giving a nice aromatic smell. Okay, like suppose I pour it over here. Okay, although it has to be poured on the body, but I pour it over here, but that doesn't mean that only this part of my cloth will smell. Now my whole body, I myself will give you a nice aromatic smell. Okay, so these are the qualities of gases. Now a quick recap of solid, liquid and gases. See, we have learned about solids, liquids and gases. Now with the help of this table, quickly we will differentiate about all three states of matters. First of all, solids. They have a fixed shape. Liquids, they don't have a fixed shape. And gases also don't have a fixed shape. Solids have a fixed volume. Liquids also have a fixed volume. But gases, they do not have fixed volumes. Solids, most of the solids cannot change their shapes easily. Liquid, they can flow from high to lower places. That means their shapes can be changed. And gases, they can spread out in all directions. Okay, so they don't have proper shape. Now, in solids, the molecules are closely packed. In liquids, the molecules are closely packed. But in gas, the molecules are very loosely arranged. And the last difference is that the intermolecular spaces is less in solids. The intermolecular space is more in liquids. Okay, more than solids. And here the intermolecular space is more. It's very large. It is more than the liquids. So these are the basic differences between solids, liquids and gases. I hope you all must have understood this topic and this concept very well. Thank you.